Efficiency measures, as Matt mentioned, currently a lot of the heating in Tasmania would be electric resistance, so you've got 1 unit of electricity goes in and you get 1 or maybe 0.9, 0.8 units of electricity out. You use heat pumps and you're putting 1 unit of electricity in and you're pumping in basically 2, 3, 4 units of ambient heat from the environment into your house for free. And of course, as I said, plenty of scope for things like solar hot water on roofs to further reduce demand. So in terms of the supply situation, there's a few different scenarios to look at. Currently there is about 30% fossil energy use in Tasmania. I grew up in Tassie. I grew up in Forth, left when I was 13, unfortunately. Right next to the Forth River, up the river were a few hydro dams. I was quite amazed actually when I went to the mainland and found that what they do for electricity there is a really archaic thing where they put vast amounts of coal in what's essentially a glorified kettle to produce electricity. But now with Basslink, we've ended up in a net import situation, and there's also a bit of electricity from the gas we import via pipeline and burnt in a couple of power stations up in the north. So we see, depending on the scenarios around hydro production, probably steady, if not perhaps a bit declining hydro production. And then obviously if we want to grow electricity demand, we're going to need a lot more wind power to balance that out. So if you were to go the full scenario, 100% renewables, you could end up needing quite a lot of wind power. That's shown in light blue there. The two graphs on the left are scenarios of one, if you had lots of wind power enough to continuously export almost all of the time. And the other one is, if you had pretty much a net import-export balance, so using some electricity from the mainland to balance that out as well. And so there are obviously many issues with this reaching such high penetrations of wind. An analogy would be, though, Denmark. Denmark currently gets about 25% of its energy from wind. It's also a very small grid. Its official target is to get to 50% by 2025. And its electricity grid is operators looking at various different scenarios of how they're going to manage that. They have the advantage of being connected to the larger European system, and that interconnection allows them to balance such a high penetration of wind out a bit more. And Tasmania would also need to look at various measures. So a few of those in terms of the 100%. One is pumped hydro. So that's basically if you've got a location where you've got existing dams next to each other, fairly close. Then if you put in a reversible turbine, when there's plenty of wind blowing, you can pump water up the hill and get it back down again later. And it's about 80% round trip efficiency, so pretty good. I mean, this is something that's used quite widely elsewhere around the world for many decades. Mainly came out of the nuclear industry originally. The photo shown there is the Thomas pumped hydro system in New South Wales in the snowy scheme. So we want to possibly work with Hydro and other players in Tasmania to investigate what would be feasible, and of course only look at using existing dams to do this. But that would allow you to store excess wind energy, and get it back again later. Another key thing that will likely be important is to explore extra Basslink cables, which is something that the industry is already doing. There's a few different scenarios there. One could be to go via King Island and pick up plenty of the very good wind resource over here, because as I should have mentioned before, Tasmania has a world-class wind resource. Australia as a whole has a great wind resource, and Tasmania is even better, and King Island is likely even better. So there could be costs associated with that stop-off, so there's also the direct-to-mainland scenario as well. And that would continue to help with balancing the intermittency of wind, and potentially also contribute to the whole energy security situation. And we would also, of course, need to look at grid upgrades and augmentation in terms of perhaps extra spinning reserve or flywheels, as that's the kind of thing they're looking at in places like Denmark. So the economics and detailed modelling around jobs, prices is something I can't really give you to you today. The initial numbers around this, if you wanted to go to quite a large amount of wind, 4,000 megawatts, you'd be looking at about 500 of those 7.5 megawatt turbines. And if you're wanting to look at getting a few hundred megawatts of pumped hydro to help balance that out, at least depending on what's available. If you were able to go to a full 90% export of renewable energy, that could potentially be worth around 400 million. If you look at the current price for renewable energy, and that's just state revenue. Total capital costs, as with any renewable energy, is high because the ongoing costs are low. So, including grid upgrades, this could be in the order of $10 billion. Just to note that this isn't that kind of investment would be financed both through domestic prices and exports. So anyone don't need to do any sort of payback calculations there for 400 million versus 10 billion. It's not the full picture. But if it's anything to go off with the mainland, one thing Matt didn't get time to mention is that the investment that we did, the 370 billion for the full mainland scenario, if you put that through an investment model with rates of return same as the current regulated commercial rates of return used by the electricity industry, 9.68%, government backed, you'd see an electricity price rise of about 6.5 cents per kilowatt hour if you were to implement the mainland renewable energy scenario, which equates to about $8 per household per week for the electricity bill. So it's an increased cost, but it's manageable, and it's something that we're likely to see under business as usual anyway. And so ultimately, to fully look at this kind of scenario, there's going to need to be more detailed modelling done. And this is just a snapshot of the start of that. So looking at taking actual wind data from, for example, the Wollongong wind farm and any other wind data we can get hold of, and looking at how that can match up with demand over a year once you scale up the capacity. So looking at times when you are going to have some excess wind energy, and when you have that, you can look at exporting it. You can look at pumping water uphill, and there's probably going to be some curtailment as well. Sometimes when there's too much wind energy, and then when it drops off, you can use your other sources to back up, so your hydro and import. So that's it in terms of the idea of the scenario. So we're going to hear more from Peter Ray and Todd Hussein shortly, and is going to have a quick talk now, and we'll be answering questions about it at the end. So thanks for your time.
Thanks a lot, guys, and thanks a lot also to the Climate Action Hobart team that's made it possible for these guys to come down and share their great information with us. Next up, we've got a couple of local speakers, Peter Ray and Todd Houston. Then we'll hear a couple of words from our sponsors, our Corso. And then, as Pat said, there'll be an opportunity to ask questions. Also to sign up to the Climate Action Hobart email list to find out when other climate events are happening, and perhaps we'll work with Beyond Zero Emissions into the future. So if you're interested in getting more involved on the ground here in Tassie, do sign up. There's information sheets out the front. You can also buy the Beyond Zero Emissions outside. And also, afterwards also feel free to get in touch with you guys over email or their website. So next up we've got Peter Ray for 10 minutes and then Todd Houston for 10 minutes. Peter, thank you.
Well, thank you very much, and good evening everybody. Congratulations to the two speakers we've already heard from in producing what I think is a treasure trove of information and ideas. And I wonder, listening to it, how can we make that compulsory reading in Canberra? I guess people power is probably the answer, because other methods don't seem to have been successful so far, and what we need is a greater upwelling, as evidenced by the crowd here tonight, an overflow crowd, that people are concerned, do want to see action, and do want people to be better informed than is evident from the sort of public debate which takes place through the media at the moment and from the Parliament. And I would hope that we can all join together in making this sort of information much more widely known and understood. But what's happening around the world, I'd just like to talk about that for a minute or two to set a scene. And it is one of the major economic activities in the world. Renewable energy development hardly faltered during the global financial crisis. Investment in so many other areas dropped away. If you look at the graph for renewable energy, in fact, it continued to increase.